All right. Hello, everybody. Good afternoon. Welcome. Mazel tov. Couldn't think of anything else to say. Oh, I'm glad you're all taking some time out to come and listen to us talk about latency. We've got a really great panel set up for you that are going to argue incessantly about what means slow and fast in streaming video. I'm just kidding. So what I want to do a little bit first is do some introductions. I'm going to introduce myself, and then we're going to go through the panel and have them each talk about themselves a little bit, you know, how great they are and wonderful and espouse all their positive characteristics and whatever. But give them about a minute, and then what we'll do is we're just going to jump into questions. Probably about halfway through the discussion, we'll take a little break. We'll see if anybody in the audience has questions, and then if, you know, we'll address them if they do, and if not, we'll move back into some questions I've got prepared, and then at the end, we'll return back to questions that you guys might have developed by then. All right, myself, I am Jason Thibeault, the Executive Director of the Streaming Video Alliance. A little bit about the Alliance. We are a global trade association that is dedicated to furthering the adoption of online video and improving the experience for end viewers by enabling companies within the ecosystem to come and collaborate on specifications, best practices, functional requirements, and even standards that will help drive the way online video is delivered and experienced by people around the world. You can find out more about us at our website at streamingvideoalliance.org. Haha, that's my PSA for the day. All right, so let's go to our panelists and have them introduce themselves. To my left, from here to the end, we'll just let them go. This is Lee Kenneth from NASA. This is Rob Post from Hulu, Charley Thomas from Limelight, and Rob Dillon from Tribune Media Services. Well, Tribune Media, not Media Services.
Media Services doesn't exist anymore.
That's right, I forgot about that. So let's start off with Lee.
I'm the lead streaming engineer for NASA. We are in charge of external streaming, the stuff that you guys see on YouTube and Ustream and at nasa.gov. We're also responsible for streaming internal to NASA, rocket launches and things like that to get our video from one facility to another facility. And we're also responsible for streaming from outer space. So, yeah.
Wow. All right.
That's a tall order to top right there. That was pretty good. I'm Rob Post. I've been with Hulu for a long time. There I'm responsible for end-to-end content and advertising technology stacks. It's a good time to be part of Hulu right now. We just launched a live service about 5 months ago. So we're kind of branching out into some new territory, both operationally and technically. But all in all, exciting time for us.
I'm Charley Thomas. I'm a solutions architect at Limelight. I've been there about 10 years. I've been in the content delivery network space for about 17 years. So I help work with our customers or prospects on anything from video streaming, live, VOD, web caching, like kind of the whole gamut. So the whole workflow of getting content into the CDN and delivering it out to the edge.
And Jason said, I'm Rob Dillon. I'm the Digital Operations Manager for Tribune Media Company for now. Who knows when that's going to change, but we are in the middle of a merger, so if you haven't heard, I'll have a different title probably the next show you see me at, but I handle the technology for the digital side, so that's 42 TV stations, including Market 1, 2, and 3, a cable channel, and several forward-facing information services on the web. I handle our live streaming, dabble in some of our apps, but I do handle all our connected devices, which is what we call OTT, because we have another division that handles OTT, and I'm not allowed to call it OTT, so I call it connected devices, and handle basically any emerging technology that comes along in the space we want to play in, such as Alexa, and again, Roku, Apple TV, things like that. So.
Awesome. All right, so let's jump into the questions. Now, obviously, we've got a great mix of people on this panel. We got content owners, engineers, service providers. We got everybody from all sorts of different aspects. So I'm going to ask the question that this audience probably all has at the back of their mind is, why is my video online slow? What causes latency? Just like, what are some of the causes of latency? Anything.
Latency happens everywhere, right? So if you look at a stream, right, you look at pane to pane, right? So where the stream starts and where the stream gets consumed. I mean, anywhere in that chain, you can have latency introduced, right? So if you're talking a live stream, you know, getting the content into that publishing point, getting that even before that, getting that into the encoder can introduce latency. So I'm on the network side, you see latency introduced anywhere along that chain, anywhere from pane to pane. There's other kinds of latency too. So there's latency from a network standpoint, then there's latency from a workflow standpoint, where how long does it take me to prepare the content? How much of a buffer do I put into my content before it gets out to the end user to protect yourself from latency? So you actually introduce a delay in your live stream to protect yourself from latency in the network. So that's why, maybe 10 years ago, when RTMP was pretty big, you probably had twice the rebuffer rate because you'd have a 3-second delay from live to when it hit the edge. When they started moving more to these HTTP protocols where you're putting 30 seconds, maybe over a minute of a delay, you have less rebuffers, but you have more of a delay from pane to pane.
That pretty much sum it up?
There's not a lot to add to that. That covered it.
Well, so that's great, actually. That's fine, because what it brings up is, and what I heard from Charley is that there's really two kinds of latency, right? There's sort of network-based latency, and there's process-based latency. And so let's talk about both of those independently. Let's start off with network latency, right? So at this conference, there's been a couple of presentations on WebRTC. And everyone's been talking, as a matter of fact, today with Facebook Live, he talked a lot about the keynote about WebRTC versus RTMP and their use of that technology. Is that a silver bullet for some of this network latency, or is it just another protocol that's going to come and go, and we'll have something better in a few years? I mean, what do you guys think of that?
I mean, I don't know that WebRTC necessarily fixes so there are advantages because it's a UDP based that helps with network latency. The WebRTC fixes a big thing that fixes is client issues. So support in the browsers, be able to get everywhere. With Flash kind of going away from a client standpoint, there's a gap. So you need to have something that's installed. You need across all the browsers and other platforms. You need to have something that's secure and can scale. I don't know that it necessarily fixes latency, and if anything, it actually poses a little bit of a risk. You improve it with UDP, which gives you a little bit more buffer, but anytime you're shortening the time to live, so with the testing we've done, we see sub-second delay from pane to pane with that WebRTC, but whenever you shorten that down, you run the risk when you're on an unstable network connection that you can get rebuffers. So it fixes a problem. I don't think it's latency that's the problem that's fixing though.
Yeah.
Anybody else? Any thoughts on that? Rob, what do you guys see at Hulu from a latency perspective? Are you guys looking at technologies like WebRTC or things like that?
Not necessarily. I mean, we're early adopters of Dash here, but from a networking point of view, that's not necessarily our focus. We're kind of partnering with folks in order to help us out in this realm, but I think we really pick up kind of our latency from more of a time to delivery to the user point of view, for a quality of service kind of point of view, or time to video start or first frame of video. All the processing up front, because we were a big VOD shop and still are today, all of our processing there, we have all the time in the world to kind of prepare that content for delivery. In the live world, we're really focusing on trying to bring great customer experiences, which includes being able to not feel like you were too far behind in a live stream. And a lot of the work that we're doing with our partners on signal acquisition and kind of acquiring signals from different places is helping us in that realm, but that's still something that we need to crack. And it's an area where we're looking into in more detail, but we haven't figured anything out. That's going to be the silver bullet there.
Same here.
Well, I mean, you guys are delivering from space.
Yeah.
What are the latency problems there?
Well, the things that we do, we do a lot in the preparation of the video. We do a lot. We make sure that the cameras that we have don't have chroma aberration on them, that don't generate extra noise into your video signal, that the noise that's generated, the black noise, we use HDR cameras so that the black levels don't generate black noise. The encoders that we use that we do a 10-bit 422 downlink sometimes, and sometimes HEVC when we can do that. But we try to keep the video as pristine as possible going into the encoder so that the encoder doesn't have to work more and you don't have to do things like the buffer, let it sit on the buffer and let it clean up or use any pre-processes. We don't use interlace, it's all progressive. So we do a lot on that side to try to make sure that the video is as clean as possible before it even gets into the encoder. And sometimes we'll run it through, not frame syncs, but like video correctors, things like that, just to make sure that it's as clean as possible when it hits that encoder. And what we're finding is that if the encoder doesn't have to sit on it as long, that whole pre-processing time on the encoder isn't as quick, and it's not a lot of heartache on the encoder itself. So you're watching a GPU just, mainly just kick along instead of struggle trying to, do as fast and quick a job as it can. So we focus mainly on, making sure the video is as clean as possible before it actually gets to the encoder. And then the other thing we do is for delivering, we do internal and external. We have to run it through these like 3 checks, and it's always, I've heard it several different ways, but we call it quality, quick, and quantity, and you can only pick 2, really. And so if it has to go to a lot of people quick, and then there's a certain process we do, and if it has to be, the quality is an issue and quantity is the issue, then there's another process we take it through. But the biggest saving for us is when all of our video feeds go into one distribution house, and in that distribution house, we actually go directly into our CDNs, and we partner with multiple CDNs, so we're not going out over the public internet, or we're not doing any of that thing, so we're not increasing extra latency because we're dumping right into the CDN, and our encoders are producing the chunked packets on our encoder, so they're delivering them right into a folder that immediately gets put out to the CDN, so that reduces latency big time for us.
What about Rob? What do you guys see from your perspective?
As a traditional broadcaster, things are a little different for us, and I deal with broadcast engineers who are the most nitpicky, things have to be perfect scientists in the world. Yet my users aren't that concerned about it. If we're streaming a car chase here in LA, nobody's going to know if that squeal of the tire was 1 second off unless you were out in the house that it just cut across your yard. So we've done tests with one of your competitors, Charley, on one of their new, one of their new products that was supposed to end up being 0 latency. And it meant that the quality wasn't perfect at the beginning, but it was there and it was instant and it was lined up. My engineers loved it. My customers hated it. We got so many emails complaining about why is this horrible at the beginning. I can't watch the beginning. When it wasn't bad. I mean, we're all back from the days of real video and stuff where it buffered forever. But the consumers hated it. So I think, nothing I do is life and death, unlike NASA where, some of that stuff they're feeding back to people who have their fingers on the button to destroy something if it goes out of control. So on my industry, it's more of finding a balance. Where's the happy medium? I don't stream sports. I know as a consumer, sports latency drives me insane. I stream car chases and breaking news. So I've got to find a balance of where, I'm not 10 minutes behind, but the quality's there and the consumer doesn't complain.
I think that's a really great spot to turn to the audience and just take a show of hands. How many people feel today that the experience of video, watching video online, is good enough? How many people think it really needs to be improved? Wow. Wow, so that's interesting that you guys are listening to customers at the same time you're listening to your engineers and they're telling you 2 different stories.
Yeah, and it's the same with us. We're all in the industry. We're our own greatest critic.
Right.
You've heard it in both keynotes and in several sessions I've been in where the customer is so less concerned about what we're concerned about. And that's because it's our lives, it's what we do, and we want it to be perfect. That's just the nature of anybody in this industry.
Yeah, I totally agree. I think, in our world, being an OTT provider, the folks that, we're trying to attract are the cord cutters or the cord nevers, right? But everybody's expectation is that when we're streaming over the internet, that the quality levels will be just as good as broadcast. You know, you want to make sure that when you turn on the system, you're streaming, you know, exactly what your neighbor's streaming next door. So this is a huge area of focus for us to try to make sure that we, one, have the right kind of architecture and tools in place and back-end and client systems in place in order to make sure that we're optimizing that experience down to the end user. But at the same time, you know, it's a like you were saying, it's a balance between how you can do that quickly and also provide the same amount of quality. For like the KPIs that we use, we focus on, you know, the average bit rate. We focus on how much rebuffering there's happening and when you get the start of the first video. So those are the three key metrics there, and they kind of play an important role together to kind of balance those two areas. It's something that we're working on daily, and we're focusing on trying to improve, you know, incrementally all the time.
So I want to turn back to a little bit more of the network problems and fixing some of the network issues. You know, one of the things that was brought up in the Facebook Live architecture today, the Live With, was the use of peer-to-peer. What do you think of that technology? Is that something that you think is going to play a role in helping to reduce latency across the network, or is it just, you know, again, you know, that evil, nasty word that nobody wants to talk about?
I mean, peer-to-peer is kind of interesting in a, I think more in a scale sense, right?
Okay.
So if you think of unicast versus multicast, you know, peer-to-peer gets you a lot more scale than you can get with a traditional network. The problem is the quality experience and control of the quality of that experience and security. So there's, I mean, there's a lot of gaps there that need to be addressed. I think that the cost savings or the expansion is not kept up with, or has not driven the desire to push peer-to-peer more. So either not willing to give up the control, the QoE, or the network's growing fast enough to where we haven't had to give up that control to keep up with demand. I mean, there's definitely corner cases, right? When you have micro events that spike certain regions, that peer-to-peer would help out a lot. But again, I mean, you have to give up that control of the QoE to some extent. Until they find a solution for that, it's going to be really tough. You know, especially if you have premium content, right? You look at Hulu's content, it's premium content. You know, they're paying a lot of money to license that content. You need to make sure that you're not getting rebuffers, you're not losing subs. You know, there are probably scenarios where that's less important and you could trade that off, but it's still too corner casey. I mean, the reality is the network costs have come down so far, you know, in the past 15 years, that there's less of a reason to do it. You know, when people were paying $100 for a megabit, you know, it was definitely needed to have something in peer-to-peer. Now, you know, you're talking cents, so it doesn't necessarily make sense.
Interesting, interesting. What would you guys say about scale? So obviously, online video is growing, right? More people are watching. That's interesting. But it seems to me that we're seeing more and more events having flash crowds, more people coming to single pieces of content at one time, like the Stranger Things 2 that just came out, right? Saw a bunch of people on that first day. Game of Thrones episode, see bunches of people on that first day. What's the relationship between scale and latency, and how do you fix that problem? Does latency increase as scale increases?
I'm not going to address that question, but I had a question addressed to Lee at lunch, and he's got a great story about it.
Yeah, we did everybody witnessed the eclipse that was like a couple of months ago, and what we tried to do, we knew there was going to be millions of people seeing this, and we kept going to everybody and go, there's going to be millions of people watching this, and they're like, yeah, we're good, our CDN's great, and so we had Facebook, and we had Twitch, and we did YouTube, and Ustream, and Akamai, and Limelight. I mean, we got everybody in bed saying, we're about to break the network here, everybody. I mean, when in Facebook, when you have all these invites, you set up an invite to come watch a stream, and you see there's 4 million people who want to know when you're live. And to flip that button, we had the Facebook people sitting on the telecom with us wanting just to flick the invite button because there was going to be 4 million invites that went out to get people to watch the stream. And as soon as the stream start, in the 4-second window when the stream started, we went from 0 to 8 million.
Oh my God. Wow.
And it wasn't the fact that the CDNs couldn't handle it at that point. The CDNs were doing great. It was actually the network backbone, the Verizons and the L3s and the big players like that were actually causing issues for people to see it. Because you had mobs of people in certain areas in big cities. They were all on their cell phones or they were all on their laptops, and they were all going to this one destination. And so to me, when I look at the pictures of WebRTC and I see how they're sharing packets, I just see even more of a bigger network nightmare of how packets are going between all these different places. You're just putting more data on the network of an over-congested network as it is. So, yeah, so we were seeing that, not really latency from the CDN part, but the latency of the actual network providers, the Verizons and the L3s and the people like that.
Is that problem even solvable? I mean, I'm asking the killer questions here.
Yeah. Hopefully by next year when we do our first launch.
Yeah, I guess my personal take on it is a bit different. That's a great story, but I think the way that we've architected our platform is to try to obfuscate some of the live and the VOD, trying to avoid some of those scenarios. I think if we execute the product well, I think there's very few things, at least from a premium content side, where people really need to see it happening live. Even when I'm watching my alma mater, Michigan State, play on Saturdays, I often join half an hour in or 45 minutes in, so I'm near live but not completely live. Things like that actually it makes it quite easier to stream, larger scale in those types of scenarios. News content, we've seen huge spikes. I think with the atmosphere today, I think everybody's trying to tune in to hear what the latest and greatest is coming out of the everywhere in Washington and in the U.S. But there we're seeing people also time shift to some degree as well. So from our point of view, we're hoping to kind of avoid some of these scenarios. Now, there are definitely still big events. We just got through hosting the World Series on the service, and we did see the highest demand. We did see huge percentage of our user base kind of tune into that programming. So we did learn several lessons there on trying to be a little bit more cognizant of these major events, kind of guesstimating what kind of load we're going to get from them, kind of running scale tests prior to those events, making sure that we have our vendors online in open call bridges, making sure that we have all the right monitoring and tools in place. This is all new for us, and we're getting the PhD really quickly and trying to figure out how to run live operations in that way. But yeah, I guess that's kind of our perspective on things here.
As a CDN, I mean, we see the premium content, we see news content, so we have a mix of content that has different kind of profiles, right? And they're pretty consistent when you look at within their spectrum, right? When you look at news, right, they want to be able to publish content as fast as they can because sometimes the difference between seconds of getting that news story out there means you're first in the search or
right.
You're on the second page, which means you're gone. So news tends to drive local micro events, right? So high congestion in certain regions. So does sports, right? So to some degree, right? So if you look at soccer, if it's your team, and it's maybe it's a smaller team or not, but in that region, it's going to be 80% of your traffic, right? So the people that are going to watch it are the people that are in that region. So it causes an issue. As a CDN, I mean, that's what we're always building out for, is to be able to do, have the network scale to be able to do it. Also have the intelligence to be able to route around that. A lot of times, people think about a caching as a CDN as getting the content as close to an end user to reduce latency, which is absolutely the truth. But it's not always geographically the closest. So, as a network, we're trying to peer with the eyeball networks so that we can reduce hops. We're also trying to get to a point where if there are micro events, we can deliver into a region from outside of the region and still get there with minimal latency. Because we want to try to keep down rebuffers. We want to try to keep a consistent experience because, we talk about quality, right? Most people would take a downgrade in the video quality over a rebuffer.
You'd think.
Yeah.
But it didn't work that way. That's it just surprised me. It's like we're getting hundreds of emails because for a second it was not in HD while everything got configured out. And it was just, to me, it was just surreal that that's what they were complaining about.
I got a question for the audience again. How many people, show of hands, how many people watch video today on their mobile phones? Yeah, almost everybody, right? So question to the panel. How does mobile complicate trying to solve the latency problem or the latency challenges with online video? Does it make it worse when you have all these people on these variable networks trying to connect to you, going up and down bit rates? Are there technologies to solve that? I mean, what do you guys think about mobile in this whole equation? How many people were watching the eclipse on their mobile phones?
We had about 40%, 50% of all traffic was on mobile.
Wow.
So of that 8 million, you can figure that out. For us, it was latency because the way it was the eclipse and things happen at NASA, it's not like an NFL sport or a video game where latency is really important. So we could actually take a little bit of a hit in the latency world. But when you're sitting there at the Cape and you're watching a launch and you got your cell phone out and you see the launch and then you look down and you see the launch. We're trying to tackle those things, but it's like you said earlier, it's not really a silver bullet yet.
The mobile networks are tricky, right? So they introduced a whole new place that we haven't had to worry about for quite a few years, which is CPU. So when you try to reprocess that content, so you have the mobile networks, which is a congestion point. So I live here in Huntington, and 4th of July, we get a couple 100,000 people that come down to the pier. And if you try to make a call during that time, good luck, you're not going to get through it. So the same thing goes with data, right? So hopefully not to that scale, but when you get a lot more traffic on these networks, they're prone to higher network latency. So if you try to bring down the pane-to-pane latency, right, where you're trying to bring it to where it's closer to live, you're going to have more and more problems with mobile. When you talk about the latencies, you've got to trade off one to the other, right? And with networks, with mobile networks, it's more of a challenge. And then you throw in that you have a CPU that has to take that content and decode it and display it, and potentially either you have to trade off some battery power. It's a challenge, right? And I mean, the phones are getting more powerful. The networks are, the networks that are going out there are expanding, so it's getting better. But expectations are growing just as fast, right? So the reality is, it's as it gets better, you're chasing to keep up with what people are expecting to see.
Yeah, and like you just referenced, most of the issues that we're seeing, they're as we're, NASA has a place where you can go vent, it's like feedback under your streams. But what we're seeing a lot of times is we're starting to ask people what cell phone were you on, what carrier were you on, just to see if there's a certain thing that we're looking, and there's a lot of still old phones out there that don't have the processing, that the latency on those are way out compared to some of the newer ones. So we hear them complain about it, but then it's like, what kind of phone you have? I'm sorry, there's nothing we can do about it at this point. So.
Interesting. All right, audience, questions from the audience. We'll take a little pause here. Does anybody have any burning question about latency directed to one of our panelists right here? And it's okay if you don't right now. We've still got a lot of questions. Dom.
Do you think technologies like LTE broadcasting and MDMS and the carrier networks are going to make a difference to the mobile phones? Scaling in a more multicast fashion, right down the access network.
So let me repeat that question. Do you guys think technologies like LTE-B will add or fix some of the latency problems with mobile networks?
You're going to have, so we talked about mobile networks, right? There's phones and there's networks. So if you improve the network, it's an improvement, right? So as long as we can keep ahead of the curve on expectations and the network, I mean, the qualities are going up. I mean, it'll help. I mean, whenever we can get more,
Yeah.
You know, when we're trying to expand our network, it's like, can we give you more, and will that help? Oh, always, give me more.
And there's always so we've improved the network exponentially by this, but also now we're going to stream 4K to your cell phone. So you just wiped out everything you just saved. So.
I think the question was regarding multicast broadcast networks on the server, right? Well, it's probably, LTE broadcast is probably 18 months to 2 years away from being anything widespread, but as technologies like that, it's a new opportunity for technology like multicast to get out and access networks. I think that's really, personally, I think that's really cool. I just wondered if you guys are seeing it on your horizon.
Yeah, we're actually doing some tests internal to NASA at this point, because that technology is not everywhere at this point. But there are some colleges that we work with, Berkeley College, Caltech. There's some vendors, some rocket vendors that we deal with, Orbital ATK, and those that actually are on that network that you're talking about. And we can actually generate a multicast signal internal to our system and be able to serve them over that network, which is really neat. Because at NASA, internally for latency, we use UDP multicast internal because it's just the quickest and fastest, and it can go through the network real easy. But external seems to be our big, once you get over that hill to go to the public. But, as soon as this network technology catches up, I see that being that will be the silver bullet. But there's switches and routers and everything like that got to be replaced. It's like billions of dollars of investment before we're there.
Question.
Yeah, you started the session by talking about the two types of latency, the network and the processing. I'd like to understand a little bit about the processing side.
I'm going to get there in just a sec. Yes, excellent question. So if we don't have any other questions, let's do that. Let's delve into the other kind of latency, right? This process-based latency. We have a question?
Question, but just an extra point that I think we should be including in the conversation. I work for Stack Tap and other CDN out there. One additional way that we think about latency that I would encourage everybody else to think about as well is the application of it in terms of on-demand video, of course, live, which is what we've primarily been talking about. The third would actually be what we consider real-time. So, the StreamPro example, of course, would be like a real-time chat. But now imagine you're in an environment where you have a video that's live and you want the real-time chat to correspond with that video and correspond at the right point in the timeline. That's a use case that we do see fairly frequently. So that's one way that I think we tend to look at latency and how we delineate it and how we go about addressing it. And then the other thing that I would say is, the way that I often hear about latency in terms of where everyone's really focusing on it, of course, has to do with when do we get to the point where the latency is low enough that the open web itself becomes a reliable mechanism to actually transmit video rather than going to the closed systems that we have today. So anyway, not really a question, but just a couple of other thoughts I thought we should.
Gotcha.
Thank you for that. All right, so let's talk a little bit about process. We'll come back to your question at the end. So the process kind of latency, right? And Lee, you touched on this a little bit at the very beginning when you guys talked about sort of things you did to the video prior to ingesting that signal into your network. So can you talk a little bit more about that?
We actually have a team at NASA that's we call it the Digital Television Video Group. And they're constantly testing video encoders. And I encourage everybody to go to nasa.gov and look up video encoders, because they're currently looking for a new or other alternative HEVC encoders to put on the space station. It has to be space rated, and there's a whole bunch of caveats.
Vendor alert.
Yep. But we're constantly testing encoders to see, how quickly can the encoder from the ingest point put it out.
Right.
And then we're also testing it, like how much buffering or how much can we do to the video inside of the encoder before it comes out. But before it even gets to that, we've done a huge study with PQI analysis, which is a high-end video analysis to tell you what kind of noises are ingested in the video before and after to see what kind of damage encoders are doing to it. And we've noticed that the cleaner the video we put in, that there's less noise on the outside. And so we try to do things like we use HDR and 10-bit 422 video, because it's the noise, the static that you see in the shots, or the chromic aberrations where it's not really red, it's not really green, it's not really blue, but it's trying to figure out what the encode is. And we're finding out that if all the way down to the lenses that are put on the cameras that are on the space station, they're gone through this rigorous test so that, you know, we're not putting all this extra noise, and the video is as clean as it is possible, and that the transport mechanism that we're using to get it from space down to the ground and to the encoders, that whole process is looked at every other day, and that there's just a team that just sits there and does that, says how can we improve the signal from the space station to this encoder. And we're noticing that the cleaner the signal is coming into the encoder, that the less the encoder has to work, the quicker it puts the packets out. And then also on the other end, if you've got a clean video signal going out and your packets are really clean, the CDN people like those, because then it's a kind of a constant bit rate that they're having to deal with. There's not a huge up and down in the bit rate. And so it just helps to start the whole process with clean video is what we're seeing in our tests.
And maybe I could add a little bit more on the VOD side. So earlier I said we have all the time in the world on VOD. That's not always true for all scenarios. Near live, which is kind of like late night television, kind of news situations, or true live, which is more like a Saturday Night Live type scenario. Here, you know, we're trying to maximize how much value we're getting out of the content. So, you know, if it's a true live scenario like Saturday Night Live, we're trying to optimize the time it takes for us to kind of encode the transcode stack, and then also push out to the CDN. So we do a lot of optimizations. Think, you know, our ingest boxes where we're getting these servers, or where we're getting these mezzanine files, they're also encoders. So we're not trying to move the file around a lot on the back end. We're encoding exactly where the file is getting ingested from. We're prioritizing encodes to a really small ladder set. As soon as that's available, we'll package DRM and any protocol-specific stuff that we're doing and push to the CDNs immediately. We'll do fast passes on encoding and then fill in later. There's not too many people kind of looking for their SNL at 2 or 3 a.m. in the morning, but we do try to make it as available as possible. On the advertising side, kind of dealing with server-side insertion of ads into content, kind of interleaving it, it's challenging when you think of like how vast is there. Like the first time we're asked to play a video, we don't have an encode for that. Here we're either doing we try to do a just-in-time encode if we can, and return it quickly enough in the ad response. If we cannot, then we kind of offload it on the side, get it done, so the next time we see that vast response come back, we're able to utilize that creative. So a lot of things where you're trying to do something, near real time in order to kind of speed up any sort of processing that you have to do to the video there. Those are just a few of some of the tricks that we've used to get that going.
Rob, what about on your team? Are you guys doing anything to the video before you?
You know, once again, the traditional broadcaster is very different for me in the fact that all the things that Lee mentioned, we all know the more noise you introduce, the more possible problems you have on the end, but I really don't have a choice. I get a transport stream from my master control that runs through a Blackmagic router. It's that way at all 42 stations, and if I was to go tell a station engineer I need a lens changed, I'd be laughed out of the building. So the way I handle it on the hardware side is I provide the best possible equipment that I can with my budgets. So I have, you know, high quality Sencors and Elementals in every station. The ones that we know are tested and will put the least amount of problems going up to my CDN. And once I get it from the transport stream and kick it up to my CDN, I just kind of cross my fingers, because then it's out of my hands and I can't handle it. And then we're back to the other side of latency and how do we control it. I know, like Lee's talking, lenses and anything you can do to clean up that stream coming in is fantastic and it's great. And I've had times where I've had to explain to engineers how I can pull something off of a Verizon modem in the field through a Teradek and have less latency and less problems than what they're feeding me out of master control.
Wow.
They just don't understand that, but it's because when I control end to end, I can tweak what I'm doing on the other side to make sure it's going in as clean as possible.
Well, it sounds like that one of these process issues that contributes to latency is, you guys have all talked about it, is encoding. So what can you do at the encoder in order to remove some of that latency, in order to help remove some of that noise that's coming out of the other side of it after your signal's going through the encoder? Is there anything that can be done?
On my side, I rely heavily on my vendors and working back and forth, and they'll tell me, well, tweak this, that's not working perfectly. Between the vendor who sold me the encoder, and like I said, I have very high-end encoders, and then my CDNs as well, working as all of us together to get that just last little bit that I can do, because I have no control of what's coming in. So I relied very heavily on my vendors.
Yeah, and the same thing with vendors that we work with, and that we do a series of, like I said, there's a whole bunch of tests that are done to these encoders, and it's basically, if you can imagine somebody in a room going, okay, the GOP is going to be 5, run the test. All right, the GOP is going to be 6, run the test. And so they change one parameter at a time, and they go through the whole gamut of these encoders, and they try to find the sweet spot of where this encoder, the quality and quick, what's that sweet spot where that video lives just long enough on that encoder to get what it needs to be clean enough to go out to the CDN. And we're trying to find encoders that, that sweet spot gets done quicker. And sometimes it's CPU, sometimes it's GPU, sometimes it's a combination, and sometimes, like, we were blown away a couple of years ago by a vendor that it was neither. It was just software, what they were using in software.
Yeah, on the offline encoding space, here we've dabbled with kind of parallelizing as much as we can. We've found that sometimes that's a little bit more challenging to kind of do all the coordination to kind of stitch it back together at the end of the day. But we have what we call a video optimization team in our office in Beijing, and we have a lot of researchers focusing on kind of the trade-offs between good subjective quality, objective quality, and also perceptual quality, and when it turns around to processing time on the video. So we do have a little bit more time in order to process the offline stuff, except in those live scenarios. But all in all, it's an area that we're trying to tweak the encoders as much as we can. We're an FFmpeg shop. We do almost all of our own encoding on our own bare metal boxes, and we've optimized a lot of the codecs from where they were to what we're using today. So we've actually put a lot of work into trying to speed up the system while trying to get the best looking video with the least amount of bits.
Yep. Any thoughts, Charlie?
Yeah, I mean, we mostly the content's packaged before we get it. I mean,
Right.
there's some exceptions, right? So we do some segmentation of content when we're doing transmuxing to convert. So a lot of times for live, we're sent an RTMP URL, and then we do segmentation. And there's not a lot that we do since we're changing the container, but not the codec. So, we can do small segment sizes so we can bring down the latency to live. We're looking at new technologies, right? So we're working on the WebRTC, we're working on the SRT as far as an import or ingest to try to improve the time and latency for the first mile. So I think the first pane that comes in. So reduce network latency, reduce the amount of time that packaging takes. But other than changing the segment size and doing things like that, and again, you're going to trade off that latency to live for increased risk to latency in the network. So if you're dealing in an audience that's mostly North America or mostly well-developed locations, you can get away with a really short segment time. If you're trying to get in through other places like LATAM or some places in APAC, China, you're going to have a really hard time if you bring your segment sizes too long or too short. You're going to have way too much rebuffering, way too much latency introduced.
All right, let's turn it back to the audience again. So we had a question back there. Let's have that question.
So we spoke about a couple of times of latency. How important is stream switching latency for users? So for example, switching between channels is experience, but as we have more video experiences where you have multiple angles or multiple streams, switching between those experiences on the user side, how important is that component of latency?
So to repeat that question, how important is stream switching latency?
Are you saying switching between channels in a live environment or switching between?
Switching between channels in a live environment or switching between different experiences within the same live channel?
Yeah, we did an event. I'm gonna see if this touches on what you're talking about. We did an event at Kennedy where we had like 6 or 7 cameras, and we delivered it so that you could actually pick which camera you wanted to be. And what we didn't want to happen was, as you hit one camera, the launch was about to take, you switch to the next camera and it's already launched. And we worked with a way, with our vendor, that we actually embedded the time code into the stream. So all the streams were, at NASA, we do time code, but the time code is the actual time. We run a real-time clock into it, and it's Greenwich Mean Time. And so if you ever try to figure out what time lunch time is, don't try to figure it out at NASA because you'll be way off. But they were all synced to a time code, and the way we were able to deliver it out to the CDN and the player, it actually pre-buffered a little bit, so it'd have a bunch of the packets. But then as you switched between camera and camera and camera, you were actually synced up based on time code that was embedded into the video. Does that answer? Okay.
Other question?
Yeah. Any of you done 360 VR streaming? What addition?
Have any of you done 360 VR streaming and for
Yes.
live? And if so,
Yes.
what additional latency constraints does that introduce?
Basically, with the CDNs, when you talk VR to a CDN, they're like VR, and then you say, "Can you do 4K?" And they're like, "Oh yeah, we can do 4K." And so it's the same latency issues that they're having trying to deliver 4K. Again, as network improves, we find ways of, trashing the network by putting more stuff out there. There's not really much you can do with VR other than clean it up on the other side and make sure that when you're delivering it to the CDN, like you were saying earlier, make sure there's not a ton of hops between you and getting it to the CDN. One interesting thing that NASA is doing is a switched VR event. So imagine that it's a live event and there's multiple cameras and you put on a headset and they're switching between 6 or 7 cameras in VR, and they're putting up live, 16:9 video inside the VR world to give you a bigger experience. So.
Sounds like it might make me sick. We do have some VR experiences, and just as he said, it's actually just a 4K video with HEVC, and then we do all the tricks at the player level in order to make sure that we can render it really good on the device. So at the end of the day, for the CDNs, it just comes down to HEVC 4K video.
Any other questions? Okay, I've got another one. So I've got 4 very unique people up here from 4 very different companies. Let me ask you guys a question on the panel. How many of you knew each other before you were on this panel? Exactly, right?
Does lunch count?
No, lunch does not count. So that brings up an interesting point. You guys are all trying to solve latency challenges and latency problems sort of in your own worlds, in your own black boxes. How do we come together to connect with each other better, to solve the problem of latency as an industry versus just doing it at an individual company level? What do we need to do? How do we communicate better?
I would say I sat here with not this Hulu guy, but another Hulu guy, probably about 6 years ago or 7 years ago, before it was even a Hulu. And there was 3 or 4 guys, and we were all sitting in the same room trying to figure out the same issues together. So, going to conferences and sitting down and learning, and as everyone on this panel probably tell you, it's not us that's going to figure out the answer. It's going to be what the consumers demand. We can come up with the best technology in the world. WebRTC may be the best technology in the world, but if consumers hate it, it's not going to help us at all.
Yeah, I think one of the really exciting things about working in this space is that it's so rapidly changing. The industry from a streaming video point of view is relatively young, and business models are changing often. We have to react to the market very quickly. I think there are, a small set of folks, and it really just takes the whole end-to-end kind of perspective, everything from a content programmer all the way down to ISP or even device manufacturer at the end of the day, to kind of make sure that we're aligned on a lot of the same terminology. I think that's one of the areas where we're not always comparing apples to apples when we're sharing data between each other, and just focusing on those high-level scenarios and kind of making sure that we have good end-to-end ownership across the board. I think that's, I'll put a small pitch in for the Streaming Video Alliance. I think that they do have a group of folks that does have that end-to-end kind of value chain perspective in play there.
I'll be honest, I was looking for the pitch.
Yeah, I thought you were leading us into that.
Yeah, that's where he's going.
But agreeing with what everybody else said, standards would help, but in lieu of standards, which we move so fast, it's hard to get a standard before the next shiny object comes down the pipe. An advocacy group or a trade association, these shows are critical that we can all get together and talk and hear other people. The Facebook presentation this morning, my company has a very deep relationship with Facebook, and I do Facebook Lives all the time, and I still didn't know all of that. That was new to me, almost everything he presented. So the opportunities to share and an advocacy group, a trade association, these are critical because I've got maybe 15, 20 more years in the space before I retire or God forbid, something worse. I don't see us ever having a set standard. It's just moving too fast.
From the CDN side, we kind of hedge our bets, right? So we're always looking to see what technologies are out there, what might be the next thing. So we have programs that are in there, and we're working with our customers. So we've got things always in flight and limited availability that we're checking out. But it's about adoption, right? So we can, as was said earlier, right? We can deploy the best thing out there, but if it can't get out to the audience, then it's useless. So we've got both sides, right? We've got to get it out to the edge. We've also got to work with the content providers that are publishing the content and make sure that we can have the broadest swath of technologies available to get the content in. And then we need to be able to get out to the most possible people. The rest of it, from a CDN standpoint, we have to spend a lot of time on that doesn't matter to most people. In this room, right, is all the network stuff that we're doing, all those things that are kind of black box from a CDN standpoint. We've got different groups that we have to go to, when we're setting up our peering, when we're setting up all these connections, where we put our locations in. There's always communication. There's groups that have to go on there, and you're trying to think ahead. What are we going to be able to put in that in 2 years is going to be able to keep us there? Maybe not 2 years, maybe 8 months.
Yeah, I mean, the real reason I asked that question about sort of how do we come together and solve this problem is because there seems to be, in the real world, ramifications for latency events, right? So how many people, wow, this is going to be, have like no show of hands, but how many people watched the Mayweather fight that Showtime streamed online? There's like 2 people kind of like, yeah.
Successfully.
Yes, success. And that's my point. So what happened with that event, right? So Showtime had a huge problem with quality, and the consumers came back after Showtime. So there seems to be a business implication now if you have latency problems and your stream experience is not what you're promising. So that's kind of why I was getting to that point of like, how do we come together and solve this? Because what happens if, consumers go, hey, I could watch another boxing match on another provider and it was flawless and beautiful, and Showtime was terrible, so I'm going to sue Showtime. And now there's this, well, what was Showtime doing differently than this other provider? Why couldn't they do the same thing that they were doing? And so I'm just trying to figure out how do we share that information, amongst ourselves and amongst the industry so that we can all glean from these events how to do things, not the right way, but the best way.
Yeah, I mean, as an aggregator myself, I'm in that situation all the time because at the end of the day, the consumer is looking at our platform, our service. It doesn't matter if it was a signal acquisition problem or a CDN problem or a AWS problem or whatever the hell it was. They're looking at us to deliver the service. We have traditionally kind of done a lot of the engineering in-house ourselves, but as our kind of service area grows, we do need to be reaching out and working with more partners, looking at some more of the industry specific metrics or metrics that other people use as well so that we can kind of compare notes. And we found that recently when we were launching the live service that we did take a lot of steps moving towards kind of using more standards-based workflows, using more measurement standard kind of industry practices, has helped us at least be walking into rooms and talking the same language as other folks.
Right.
So that's been helpful, just like I said earlier, just comparing apples to apples in some of these areas.
Yeah, I would say we deal a lot with vendors, and because we are in NASA, we're kind of not competing against each other. So to us, people will walk in the door and tell us things that they won't tell other people. But as far as standards as NASA goes, I think this is I've worked in all kinds of television and streaming jobs. But working at NASA, this is the most testing organization I've ever been in. I mean, they test the mess out of things. And then they produce papers that you guys can go get. There's actually a NASA digital television standard, and it's basically what NASA's chosen as, after testing all of this stuff, like how you should set things up. It's a television standard. You can actually Google it and go download the paper. And then there's a web video standard that you can go Google and download. And it kind of has some of our presets in what we do. I mean, the American taxpayer paid for it, and it's theirs anyway. But it's yours to go get. And just look up NASA television standard or NASA web video standard. You can download those documents. And they're reviewed every year and updated. And we're reviewing them this year to add in some of our new HEVC standards, that how we're going to set things up and how we handle captioning. And for us, we have to hit as many users as possible. So yeah, new technology comes out, like HEVC came out a couple of years ago, and we wanted to jump on it, but to deliver it to everybody wasn't there yet. And so it didn't make our standards until this year, as we're talking to Verizon and other vendors saying, hey, it's going to be in cell phones, it's going to be here, it's going to be there. So we went ahead and addressed that, and that will be in our upcoming standards. But that's something you guys can go and get. Just look up NASA TV standards and NASA web video standards.
Yeah, so the advice there is you don't have to do it yourself, right? There's definitely content and resources out there to help you solve some of these latency problems with, best practices and things like that. All right, one more time, turning to the audience. Questions for our panelists? No more questions. All right, listen, let's give a round of applause to these guys. They were fantastic.